Assalamu alaikum warahmatullahi wabarakatuh. We have completed chapter number 6, heat transfer. Today we are going to start chapter number 7, sound. Now let's see what is sound. It is a form of energy that produces a sensation of hearing in our ears. So sound is a form of energy that produces a sensation of hearing in our ears. And it is always produced due to vibrations. Sound is produced due to vibrations. When an object vibrates, sound is produced. When the object stops vibrating, sound also stops. Thus, only vibrating objects produce sound. Now this is a ruler. Can you hear any sound? Now I am going to vibrate it. Now when it vibrates, sound is created. So sound is produced by vibrating objects. Now this is a string which is stretched between two nails which are 100 centimeter apart. Now plug the string in the middle. What do you observe? You observe that the string starts vibrating and simultaneously a sound is heard. After some time, when string stops vibrating, no sound is heard. This shows that a vibrating object produces sound. Now I have taken these two pens and I have stretched a rubber band between these two pens. Now I am going to plug this rubber band and now let's see what's going to happen. Now on plugging we can hear a sound. So this is due to the vibration of the rubber band. And this shows that vibrating objects produce sound. Now sound travels from one point to another with the help of vibrations of particles of the medium. So sound needs a medium to travel. Sound needs a medium for its propagation, means sound needs a medium to travel from one point to another. So this medium can be solid, liquid or gas. Sound cannot travel without a medium. Sound cannot travel in vacuum. It needs a medium, whether it is a solid or a liquid or a gas. And it travels fastest. It is fastest through solids, little slower through liquids and slowest through gases. So the speed of sound in iron is nearly 5950 meter per second. In seawater it is nearly 1531 meter per second, and in air at room temperature it is nearly 340 meter per second. So it is fastest in iron and slowest in air. So this shows that sound travels fastest through solids, little slower through liquids and slowest through gases. Now propagation of sound. Let's see how does the sound travel from one point to another. We know that when an object vibrates, it produces sound. Just now I have shown you also. Now sound travels in a medium with the help of vibrations of particles of the medium. The particles vibrate and sound travels through these vibrations. So these vibrations while traveling create a periodic disturbance in the medium. So when sound travels, it creates a disturbance in the medium. This disturbance travels in the form of waves. So sound travels in the form of waves. Sound travels in the form of compressions and rarefactions in the given medium. One compression and one rarefaction together constitute one wave. The wave in which the particles of a medium vibrate to and fro or back and forth along the direction of propagation of wave is called a longitudinal wave. Thus, sound waves are longitudinal waves. Now, these are the terms related to a sound wave. Number one is amplitude. When a sound wave travels or propagates through a medium, the particles of the medium get displaced from their mean positions. The maximum displacement of a particle from its mean position is called amplitude of the wave. Now the terms related to a sound wave, they are: number one is amplitude. Now what is amplitude? It is the maximum displacement of a particle from its mean position. Now when a sound travels, it travels in the form of wave. So when this wave travels through a medium, the particles of the medium get displaced from their mean positions. So this displacement from the mean position is called the amplitude of the wave. And this amplitude is denoted by A. This is the displacement from the mean position and it is denoted by A, and SI unit of amplitude is meter. Now second is time period. What is the time period? It is the time taken by a particle of a medium to complete one wave. And what is one wave? One compression and one rarefaction makes one wave. So to complete one wave, the time taken is called the time period of the wave. It is denoted by capital T. Its SI unit is second. Now what is the frequency? The number of complete waves produced in 1 second. Number of complete waves produced in 1 second is called the frequency. Since one complete wave is produced by one complete vibration, hence frequency can also be defined as the number of vibrations per second. So number of complete waves produced in 1 second is called the frequency, or frequency can also be defined as number of vibrations per second, as one wave is formed by one complete vibration. So it is denoted by small f or small n, and its SI unit is hertz. Now what is wavelength? It is the distance between two consecutive compressions or rarefactions. It is also defined as the distance covered by the wave in a time in which a particle of the medium completes one vibration. So what is the wavelength? It is the distance between two consecutive compressions or rarefactions. Now there are two compressions and there are two rarefactions. So this is the wavelength. It is denoted by lambda and its SI unit is also meter. Now what is the relationship between time period and frequency? We know that time taken by a particle to complete one vibration is called the time period. Therefore number of vibrations in t seconds is 1. Number of vibrations in 1 second is 1 upon t. But we know that number of vibrations in 1 second is called the frequency. Therefore frequency equals to 1 upon time period, or f equals to 1 upon t, where t is the time period and f is the frequency. Now how is a wave represented? It is represented by two graphs, displacement time graph and displacement distance graph. So displacement time graph shows the propagation of wave with respect to time. This is displacement time graph and this is displacement distance graph. Here there is displacement and time, and here there is displacement and distance.